Hello there guys, and in this Linux tutorial what we are going to talk about is the difference between symbolic and hard links. Okay, so what we talked about so far is permanent storage devices, partitions, file systems, inodes, and the links. And today we are going to put all of that knowledge to use and talk about the difference between symbolic and hard links. And before we get into this, let me just say that this is very important to understand, no matter if you're a professional computer user, such as a software engineer or someone else, system administrator, or if you want to use computers just for like your regular day-to-day use, you will sometimes, most likely, encounter broken links. And then in order to truly understand what is going on, you will need to know this. Okay, so please pay close attention. Okay, so let's review some stuff first. As we already know, a file is represented as an inode. More accurately, an inode tells you where the file is in the data pool, among other things, but in essence, a file is represented by an inode. We also already know that links are pointers to files. There are two kinds of links: symbolic, also called soft links. So basically, symbolic links are also called soft links, and hard links. And so now let's explain the difference between soft or symbolic links and hard links. And let's actually use an example to illustrate this difference. So if I type in LSL, and for example, let's look at these two files, 1264.txt and 2345.txt, I can see that their link counts are 1. Okay, so they only have one link, which is basically, and as we said, links are pointers to files. So they only have one pointer pointing to them. Okay, so now let's look at this. Let me do this. Let me create a link to the file 1264. So I will use the ln command, and basically the ln command, which I'm using right here, is used to create links. Okay, so ln 1264.txt, and I'm going to name the link 1264 hard, because this is going to be a hard link. Now I will also create a symbolic link, and I will call it 2345, and I will call it 2345 symbolic. And again, I could also call it 2345 soft, but I like the symbolic term better because I'm more used to it. But you can also call symbolic links soft links. Okay, and now that I press enter and I type in LSL again, I can see that the link count for 1264.txt is now 2, while the link count for 2345 is 1. Now you may wonder, okay, Mislav, what just happened? Well, we created two links. Shouldn't this link be 2 as well? Well, the answer is actually it shouldn't. Okay, it shouldn't. And now you may ask yourself, well, why doesn't it? Why shouldn't it be? Why shouldn't it be equal to 2? Well, because of the thing I am going to talk about to you right now. And let me just switch to my drawing board. Okay. So let me draw the situation we are currently having in our command line. So basically, we have an inode, which, again, as we said, represents the file's data structures and everything, basically the underlying file data. Okay. If we have a hard link, okay, so if we have a hard link actually points to the underlying data. Okay, so the hard link points to the underlying data. And if we have some file, let's name it some file.txt, and it's here, that is also pointing to the underlying data. Okay, so basically, if we have a hard link and if we have some file which is actually just a file name with its appropriate extension, or sometimes you don't even need to have an extension, you can just have a file name, it is also pointing to the underlying data. Okay, so basically when you create a new file, well, that file is actually a link to the underlying data. Okay, that file is associated with the underlying data. However, a soft link or a symbolic link, but I'm writing the soft link because it's easier for me to write here. Soft link actually points to the file. It doesn't point to the underlying data as hard link and like I would say regular file names do, but soft link actually points to the file. Okay, it doesn't point to the underlying data. So this is why the link count doesn't increase. Okay, so when you create a hard link, you actually do have more links because links actually point to the underlying data. While instead, if you have a soft link, it doesn't increase the link count because you're not pointing to the underlying data. You're actually just pointing to this thing right here. And then this thing right here, which is like a regular file name, is pointing to the underlying data. Okay, so this is actually what is happening. And this is why soft links don't count as links in the link count column in the ls command, because they don't point to the underlying data. Okay, and now let me just show you one more thing. So let me print out the contents of 1264.txt. So what? Sorry, 1264.txt, and then let me also print out the contents of 2345.txt. Okay, and now let me print out the contents of 1264 hard, and let me print out the contents of 2345 symbolic. Okay, so these things work. Okay, so hard links work, symbolic links work. We can actually access the underlying file both through this and through this. But now watch this. Let me rename the file 1264.txt to 1264 new.txt, and let me also rename 2345.txt to 2345 new.txt. Okay, and now let me type in LSL again, and basically, as you can see here, nothing's changed. Okay, so 2345 new has one link pointing to it, and 1264 new has two links pointing to it. So I just basically wanted you to see this because I haven't mangled around with the links. I just renamed the files. Okay, I just renamed the files. But what happens is if I try to print out the file in 1264 hard, that will work, okay, because the hard link is pointing to the underlying data. And if I press enter, I can see that I can still access the underlying data no matter that I changed the name of the file to 1264 new. However, if I type in cat2345 symbolic, that doesn't work. And why doesn't that work? Well, let's just go to the image right here. That doesn't work because a soft link or a symbolic link isn't actually pointing to the underlying data, which is the side node. It is actually just pointing to the file name. And actually, then that file name is pointing to the underlying data. But if the file name changes, then we have what is called a broken link. And you can actually see this broken link by this red color right here. Okay, so before, if we go to our ls, we can see we had 2345 symbolic. It was this blue serene color. Okay, there was no red color. And now when the link breaks, we actually have this red color, which indicates, okay, this is a broken link. Okay, this doesn't work anymore. Okay. So that is the difference between hard and soft links, and that is the reason why not all links count as links to files, because as you just seen, hard links points to the underlying data and soft link points to the file name. Okay, and then that file name points to the underlying data. Okay. So this is pretty much it, guys, for the difference between hard and soft links. I hope that you learned something useful, and I hope that you will stay together with me so we can go along together on this Linux journey furthermore. Okay, and I don't really think that this sentence was grammatically correct, so I think it's a good time to end the tutorial here. Okay, so thank you for watching, and I hope to see you in the next tutorial. Talk soon.